Hi everyone, this is Zach. In this video lecture, we'll be talking about the basic concepts in logistic regression. And we'll be looking at the quiz datasets that we've looked at before. Notice that we have 11 students, with one of the students not the study hours not being available or being missing. Right, and as before, we can see that the study hours can be used to predict whether the student passed the quiz. So you might wonder, how do we find the best S-shaped curve that fits the probability the best? So before we get to that, we need to quickly kind of recap some of the basic concepts in probability that most of you have heard about before, but perhaps have forgotten. So first, the probability, which we usually denote by P, is basically a number between 0 and 1 that describes how likely the event is to occur. So for example, if you flip a coin that is fair, then the probability of heads is equal to the probability of tails, which is about 50%, or 0.5. If you roll a fair die, the probability of getting, say, a 3 would be 1 out of 6, since there are 6 possible values, and they're equally likely. Next, I'm going to talk about a term called the odds. So I wanted to insert this perhaps famous quote, "May the odds be ever in your favor." So what are odds? The odds are defined as the probability of the event divided by the probability of the not event. So this is the same equation, perhaps written a bit more nicely. Basically, the odds is a number that is always bigger than 0. If the odds are equal to 1, that means the event is equally likely to happen as it is to not happen. So basically, the probability is 0.5. If the odds are bigger than 1, that means the event is more likely to happen than not. And if the odds are less than 1, the event is more likely not to happen. So finally, there's something called the odds ratio, and that's where we go back to the data we looked at earlier. So in that data set, we have 5 females and 6 males. 4 females passed, whereas only 2 males passed, perhaps because they didn't study as much and were playing, computer games too much or something. Anyway, the pass probability for females is 0.8, whereas for males it's 0.33333. And if you calculate the passing odds, you'll get 4 for females and 0.5 for males. So if you can then compute something called the odds ratio for males to pass, which is the odds for males divided by the odds for females, and that's 0.125. So this basically means males have a 0.125 times odds of passing compared to females. Alright, now let's get to the logistic function. This is a plot of the standard logistic function, which is the S-shaped curve that we saw earlier. And this is the equation of the logistic function, which is good to know. But basically, somehow it magically gives us the beautiful S-shaped curve that we want. The logistic function maps a number x to a probability p, which is strictly between 0 and 1. And what you notice is that as x increases, the probability increases until it gets closer and closer and closer to 1. And as the probability decreases, as x decreases, the probability keeps on decreasing until it gets closer and closer to 0. For logistic regression, this is the notation that we use. The goal is to predict the response variable y using the explanatory variables x1, x2, and 2xk. And the probability that y is 0 is basically given by this expression. And f maps this linear expression into a probability using the standard logistic function. We can map this expression into a probability between 0 and 1. And when we estimate a logistic regression model, we're trying to choose the best coefficients, beta 0, beta 1 to beta k, so that there's a high predicted probability when the event occurred and a low predicted probability when the event did not occur. Another term that we need to know about is the Logits or Logits, which is the log of the odds. Basically, because in the linear regression the odds are this expression, the log odds becomes a linear expression that we've seen before in linear regression, is exactly the same as the kind of linear regression model that we've seen before, the linear regression equation. And just remember, the logit and the odds kind of behave in the same way. The bigger the logits, the bigger the odds, the more likely that y is equal to 1. Alright, so how do we interpret the coefficients? So basically, if you increase xi by 1, that's the same as multiplying the odds by the exponential of beta I. So basically, if beta I is positive, increasing xi increases the odds, whereas if beta I is negative, then increasing xi decreases the odds. And just as a quick reminder, this is what the exponential function looks like. If you take the exponential of 0, you get 1. If you take the exponential of a negative number, you get something less than 1. If you take the exponential of a positive number, you get something more than 1. Alright, so there's a very simple way that you can convert the logits into a probability using the fact that logit is the log of odds. So you take the exponential to get the odds, then you have this equation, which is basic algebra, to calculate the probability. And similarly, you can convert the odds, the probability, into logits by calculating first the odds, then taking the log. Alright, so the key takeaways from this lecture are we've learned about some of the basic concepts in probability theory, which are the probability, the odds ratio, and the logits. And we've also learned about the logistic function, which is an S-shaped curve that's used to map the logits into a probability. In the next lecture, we'll see how we can estimate logistic regression models in R. So see you next time. Bye.